Let's have a look at question 1 in this video. So we have a utility function given by the following shape, where Q is our pizza consumption and Y is the composite good. Now we assume that the price of pizza is P euros and the price of the composite is 1. Our income is M. Compute our optimal demand function for pizza without using the knowledge for Cobb-Douglas function. Okay, so let's do question 1 in this video. We'll finish it with question 2 in the next video. First of all, it's gonna be pretty much a mathematical question. So let's write here the summary of the data. We have pizza, which is Q, and we know that the price of pizza is gonna be just P. So the price of Q is just P. We also have our income, our composite good, so to speak, and the price of the composite good is gonna be 1. Our money is M. From this data, what can we write? We can first write our budget constraint, because we'll need it. So we spend our money by consuming pizza, so the price we pay for pizza times the pizza we eat, plus the money that we spend on the composite good, which is 1 times the composite goods we buy. That's going to be our total money, which is the same as PQ plus Y equals to M. So that's one thing, that's our budget line. Now we have to keep this in mind to maximize our utility so that we can find the optimal pizza consumption, which means we are going to use our Lagrange function. So let's write the Lagrange and let's solve it. It's just going to be a bit of math recap. So our Lagrange is going to be our function y to power alpha times q to power beta minus lambda times the budget line. We take into account our constraint, which is pq plus y minus m. Now what do we do with the Lagrange? We have to differentiate it with respect to both goods. So we have to differentiate Lagrange with respect to y equals to 0, differentiate it with respect to pizza, and that's going to be equal to 0. So let's do it. The Lagrange derivative with respect to y. This is going to be our variable, everything else is a constant. So y to the power alpha derivative, that's alpha times y to the power alpha minus 1 times the constant q to the power beta minus lambda times the derivative from y, it's just 1, so it's just minus lambda equals to 0. Then we do the same for q. What is the constant here? Y to the power lambda, we keep it like that. Q is the variable, so we differentiate using the power rule, which is going to be beta times q to the power beta minus 1 minus lambda times pq derivative with respect to q. We keep just the constant, which is p. Everything else is a constant unrelated with q, so it's becoming 0, and that must be equal to 0. Now let's take everything with lambda on one side, because we're going to make it equal later on. So that would be lambda times y to the power lambda minus 1 times q to the power beta equals to lambda. By the way, I think I said lambda here. I mean alpha. I'm confusing the two always. They look similar. And here we have y to the power alpha times beta times q to the power beta minus 1 equals to lambda times p. Now we have lambda. On the other hand, on the other equation here we have lambda times p. Let's take this p on the other side by dividing it. So we'll do that, meaning that in the first equation we have lambda equals to alpha times y to the power alpha minus 1 times q to the power beta. Here we have lambda equals to y to the power alpha times beta times q to the power beta minus 1 divided by the price. Let's go below and continue. So we have lambda and lambda. That's what we wanted. We wanted something similar, so we can make them equal, which means that alpha times y to the power alpha minus 1 times q to the power b, that's from the first equation, is equal to the second equation over here. That's y to the power alpha times beta times q to the power beta minus 1 divided by p. Okay, let's keep going. Now let's deconstruct this a bit. This is going to be alpha times y to the power. That's alpha times y to the power minus 1, because we would use the power property here, exponents property, times q to the power of beta is equal to y to the power alpha times beta times q to the power. Let's use the exponents property again, deconstruct this like that. and yeah, divided by p. We could just write it here. Why did we do all that? We did it because we'd like to cancel out some terms to have it in a easier way. So q to the power beta, q to the power beta go away. We have y to the power alpha, y to the power alpha, they cancel out. So we're left with alpha times y to the power minus 1. Let's just write it as alpha divided by y, because that's the same, equals to beta times q to the power minus 1 is 1 over q. So that's just going to be 1 over q times p. Okay, what can we do with this relationship from here? Let's try and write p in terms of everything else, because then we'll substitute it into our budget constraint. So let's go a bit below to make some space. Let's do some cross product. We will have alpha times q times price equals to beta times y. If we want to keep price on one side only, so we care about our price now, that's going to be price equals to beta times y divided by alpha times q. Now let's see if we substitute this into the budget constraint, because we would like to have a demand function for q. Now that's our budget constraint from here. Let's just remember it. Actually, let's just copy paste it. So let's crop it like that, copy and paste it over here. Okay, now we're going to use this one, the price. Let's see what's happening if we're going to use the price over here. We would have beta times y divided by alpha times q plus y equals to m. Now what we can see is that q and q is going to cancel out, and in that case we're not going to have a demand for quantity, meaning that this substitution is not going to work. So how can we substitute? How can we substitute such that we keep quantity in our function? Well, because we have quantity and price, and then here we have y, we could substitute here y in terms of all these variables, and we'll keep our quantity in the function, our demand for pizza basically. Yeah, q stays for demand for pizza. So let's substitute here y. Let's write y in terms of everything else. Y is going to equal to, if we do the cross product, that's going to be price times lambda times quantity, and we're going to divide by beta. This is going to be our y. We can substitute y into our budget constraint, and now I think something is going to work out. If we put it here, we will have price quantity plus price times alpha times quantity divided by beta equals to m. Okay, we want just, I'm sorry again, I just mean q. I say quantity because I'm used to it, but it's pizza. We mean pizza, quantity of pizza. I don't know why they use these weird letters, but it's useful to get comfortable with weird letters, because you know, it's just the way it is. Sometimes you gotta do it. Now what do we have here? We have two fractions but with different denominators, so let's make a common denominator. Beta times p times q plus, we add all this, p alpha q divided by the same denominator of beta equals to m. Now let's take q as a common factor because we care about q. This is our demand of pizza. So q, if it's a common factor, what do we have in brackets left? The term from here, beta p plus p times alpha divided by beta is equal to m. We're close to the answer, I think so. Now q, what do we have common here? We have price as a common factor. Let's take that out, and in brackets we're gonna have beta plus alpha. Let's just write alpha plus beta because it's in order. Divided by beta equals to m. So we have now q. Q is the demand, remember, that's what we're looking for. Q is equal to m times beta, and we're gonna divide by this one because this one is gonna go below. So we're gonna divide by the price times alpha plus beta. And if we just write it in a more, you know, comfortable way, so to speak, that would be beta divided by alpha plus beta multiplied with m over the price, and that would be the demand for our quantity of pizza, and that would be the answer for the first question. Let's stop here and let's finish off the second question, which is going to be really short, in the next video.